This is an example of an economic evaluation of insurance, an insurance expansion, and insurance intervention, provision of insurance, compared to no insurance. This is my simplification of Peter Munich's study on the cost effectiveness of health insurance in the American Journal of Preventive Medicine in this week's readings. As usual, I just set the willingness to pay to $50,000. Earlier in the wizard, this part of the wizard will set the first payoff as cost in dollars, the second payoff as effectiveness and quality adjusted life years. Just label them, so cost, usually just label currency. You can see in sample it puts a dollar sign in front of it, and effectiveness, add a custom suffix for quality adjusted life years, and in sample you can see it will label quality adjusted life years after the effectiveness metric. To build out the tree, I want to code up a variable. We're going to say that the cost effectiveness of health insurance is a function of age. So I want to make a variable for age. We'll set that equal to 45. So we're going to model the cost effectiveness of health insurance for a 45-year-old in the base case scenario. When we have age coded as a variable, that will allow us to look at the sensitivity of our cost effectiveness model to a range of values for age. So how sensitive are the results of our cost effectiveness? How sensitive is the cost effectiveness of health insurance to different ages of the individuals in the study? For simplification, I'll just say that the quality of health insurance is 1, and then you can see there's a cost function there. So remember, the cost effectiveness we measure by the incremental cost effectiveness ratio, the cost divided by the quality. When there's one quality, the cost is the same as the ICER. So we're going to model the ICER as a decreasing function of age. So as you get older, the ICER of health insurance compared to no health insurance is lower. Lower ICER, more cost effective. As you're older, you're paying less per additional life year that you get from insurance as compared to no insurance. No insurance, I made it a placebo, so minimal cost, minimal effectiveness. You pay nothing, you get nothing with no insurance, compared to insurance. The first thing we always like to do, as usual, is we evaluate the slope of the supply curve. Click on the blue square for the decision, at choosing between insurance and no insurance, analysis cost effectiveness, shows the supply curve there. You can see that it's going to scale up the supply curve from no insurance to insurance based on the slope of that line. So remember how we calculate the slope of the line is in TreeAge we'll ask it to do analysis rankings. Rankings will show us the incremental cost effectiveness ratio, which remember is the slope of the supply curve. In this case, the ICER is $18,500 per quality adjusted life year. $18,500 is less than willingness to pay of $50,000, so it's going to scale up the supply curve. It's going to switch from no insurance to insurance. Insurance is cost effective compared to no insurance, given that we said the willingness to pay is $50,000 per quality adjusted life year for a 45-year-old. So for a 45-year-old, insurance is cost effective. Undo that rollback, and now we'll do a sensitivity analysis. Sensitivity analysis allows us to look at a range of values for age and how that affects the ICER. So how sensitive is the incremental cost effectiveness ratio? How sensitive is the ICER to the age of the individual in question, the individual in the study? So what the sensitivity analysis does here is it shows that ICER calculation of the net monetary benefits for different values of age. So $32,500, that's the cost effectiveness of health insurance, the ICER of health insurance compared to no health insurance for a 25-year-old. $29,000 for a 30-year-old, $25,500 for a 35-year-old, and so on. And then you can just graph those values here. So on the y-axis we have the ICER. Remember that lower ICERs are more cost effective. ICERs less than $50,000 per quality are cost effective. So in this case, insurance is always cost effective. The biggest ICER you get is that y-intercept where it's $32,000. $32,000 is less than $50,000. So insurance is cost effective for ages 25 through 65, and it's more cost effective the older you are. So when you're older, maybe you do pay a little more for insurance, pay more for health insurance, but you're paying less for quality adjusted life year because insurance is more valuable. When you're older, you're sicker, you need more insurance, you get more bang for your buck, you get more value out of your insurance at older ages. So as you age, insurance becomes more cost effective compared to no insurance, as seen by those decreasing ICERs. But insurance is always cost effective ages 25 to 65 in this model because the ICER is always under 50,000.